Okay. Good afternoon. My name is John Graham-Cumming. I'm the CTO of Cloudflare. Who's heard of Cloudflare here? Oh, a lot of people. And who uses Cloudflare? Great. All right. Well, wonderful. A lot of you know what that is. One of the questions I often get is, what does the CTO do? And the truth is, not write code. They don't let me write code anymore. Here's a good example of that from the organization. This was earlier this year, and Tom Armfeld says at the bottom, "We're still fixing your bugs from 2015." So that's what they're doing. They're cleaning up the bad stuff I wrote 4 years ago. Now, to be honest with you, I actually replied to him, "Why did it take you 4 years to fix it?" Because he'd had plenty of time to fix it. But I did work on a lot of the original code at Cloudflare, but now Cloudflare's about 1,000 people, and so it's a bit hard for me to be writing code. But I do want to talk to you about coding in general, and talk to you about something that's going on with serverless or containers. Something's going on with coding, which is fundamentally different to stuff that's been going on before. And so if you sort of go back in history a little bit, at some point you bought hardware. I don't know anybody who does this anymore, but there are people who bought hardware, right? You bought servers, and you paid a certain amount for machines, and then you had like infrastructure services where you could go and rent hardware, and then actual platforms where you could deploy, say, like a Rails app or something like that. And more recently, something has developed which is called functions as a service, which is a name I absolutely hate. I think it's a really, really weird name, because what the hell is a function? Well, and actually the truth is, if you go back in time, you'll discover that we've come right back to the future, basically. So now we're trying to just think about doing some bit of coding. But if you go all the way back, like 1936, obviously Alonzo Church and Turing are coming up with the lambda calculus and fundamentals of computing, which is really all about, if you think about nowhere in there is like, I'm going to go buy a machine from Dell to do this on. It's fundamentally about executing code. And then really funny one is this paper in 1952, which is about this amazing invention called subroutines. And what's really interesting about it is this is a really, really serious document about, what would be a good idea is subroutines. And they'd be really handy to have them. We could package up functionality and they could do stuff. And the author talks about, these subroutines are going to be able to do individual things for us, but one of the fundamental problems we're going to have is, where are these subroutines available to me? Because at the time, the architecture of the machines were such that was a complicated question to ask. And so, he's saying, well, maybe they'll be on punch tape, and, when you need to call one of these subroutines, it'll get loaded into the machine and get executed. Or maybe there'll be some auxiliary storage, Mercury delay lines or something. And at the bottom, he hints at, certain machines, 1952, it might be possible to have subroutines at like arbitrary locations in memory. So this idea like there'll be functions and we could just call them. And that's kind of his nirvana, is just his ability to call these subroutines. And he kind of goes on and says, what would be really, really cool is if we can have these things, because then you won't have to worry about what is in the subroutine. You'll just call it and it'll do a thing, right? And if we can hide all the complexity, then that'll be wonderful. And that's sort of, I think, what's going on with functions as a service, is like, you fundamentally just want to write code. Like nobody really, there are some people who want to think about machines, but most programmers don't want to think about hardware. They just want to say, I got some code. And so, we just want to write code and we want to execute it. And what's interesting about the previous presentation, if you saw the Gigatron, is there's that wonderful moment where you start basic and you immediately can write some code and execute it. And anyone who grew up in that era, they never worried about all of this infrastructure. They're just like, I can write some code. And they were immediately in that. Anyone who's used languages like Lisp, where there's a REPL, you can just boom, I can just write some code. So when I think about this functions as a service thing, it's really about just liberating developers and being like, I'll just write some code and execute it. I don't care where it executes. And of course, the world is not that simple, because there are some problems with this serverless thing. Of course, there are servers, right? So if you just sort of go back in time, over time, computers have got smaller and smaller and smaller, right? So you had like large computers and then commodity servers and then virtual machines and then containers, and you were able to you are able to have 10x increases in the number of these things, right? So virtual machines, you can put 10 of them on a single machine. Then containers, you put tens of those on top. But fundamentally, I mean, what you'd like to do is just handle subroutines, right? Something happens, I handle it, and I carry on. And that's really what I think serverless is about. It's about this kind of event-based thing, which something happens, I do some compute. And I don't worry about any of the rest of this stuff. So I personally consider that containers are a kind of passé at this point. And they're interesting for certain applications, but they're very large. It's like, I'm going to take this whole thing and put it somewhere and execute it. And that's why you see like cold start times on things like Lambda being very slow, because it's a very large thing. So what you want is, you just want your function to execute somewhere, and preferably not in one of these. This is an actual Amazon data center. The reason you don't want it to execute in something like this is there's not very many of them, and they tend to be very far away from wherever your end user is. What you really want is to go back to that Gigatron experience of like, it's really close to me, I type some code and it executes really fast. I mean, every developer knows that even from a debugging or programming sense, that loop where you try something and you do it and you test it, and it's like, you just don't want to have anything get in the way of that experience. So one of the ways you can think about this is, what if instead of worrying about all this machinery, you just said, look, I'll just handle this one event or function, if that's how I'll think about life. And you don't think about where the code runs, you just run it. It runs everywhere. And what does everywhere mean? Well, fundamentally right now, it means inside the internet somewhere. Because we've all got so addicted to connecting everything to the internet that you might as well run it inside the internet, because we're all connected all the time. You know, literally as the wheels hit the ground at 12 o'clock today, I got out my phone and connected to the internet, because I was like, I've been off the internet for 2 hours. Well, actually I hadn't. I'd been on British Airways Wi-Fi. But there was like a 10-minute period where that was off, but I didn't have 4G yet, and so I was having withdrawal symptoms. But we've all got used to this, like we should be able to run stuff everywhere and get rid of the machines. And so here's an interesting thing, which is like, if you think about a lot of applications that are getting built today, they look something like this. Like, you know, some event happens, like someone calls you, and then Twilio does something and tells Stripe to do a thing, which tells an email service to do a thing. There's just, you're chaining together a bunch of subroutines, basically. And they're typically running all over the place, right? They're running in different locations around the world, different machines. But it's quite interesting if they start to get co-located, because then the performance is really, really high. And if you can break up everything into small enough functions, you can have the functions everywhere, and then you can, what you end up with is things being co-located. And so, you know, the Twilio thing can call a Stripe thing, can call a Gmail thing, and they're all actually maybe even in the same machine or in the same process. So I think there's a world in which that becomes a reality. And there's another word that's really, really important, which is geography in the world. So, you know, anyone who has traveled around the world will have noticed as they move around that certain applications get slower or faster depending on where they are. This is particularly bad if you're from Australia or New Zealand, because it is geographically very far from the rest of the internet. And so many times you'll hear people from Australia and New Zealand come to Europe or come to the US and say, wow, the internet's so much faster here. And what they actually mean is, I'm so much closer to where the servers are. Right? It's because you've got so much closer. So geography really matters here, and the internet obviously is everywhere. And obviously when we're talking about geography, we should talk about dog walking drones, because that's obviously the key application of the internet, right? So, but think about this example for a minute. Obviously you have a dog. If you have a dog, you have to imagine you have a dog, right? And you don't want to walk it, so you get a drone that walks the dog, right? And the drone can do lots of things without internet connectivity, right? It can follow a route, it can avoid obstacles, it can see what the dog is doing, can stop when the dog needs to relieve itself. So it's great. It's got a lot of compute power in the drone, GPS connectivity, and that's wonderful. And that's a bit like you're playing a game on your phone that doesn't need any internet connectivity. Lots of computers concentrated there. But unfortunately, there are many dogs with drones, right? And these dogs are then being walked by these drones, and then they're going to interact with each other. So now you have some geographic locality where the drones talk to each other and say, oh, well, I don't want to bump into each other, there's too many dogs in this park. They can do some local connectivity without internet. But what if your dog hates that other dog, right? So you want to avoid a specific dog. And so you know how that's going to work. You're going to get out your phone and you'll be like, yeah, my dog hates that dog, I'll configure that it never walks near that dog, right? And because if it does, this happens, right? So you have this argument. So the drone needs to do dog avoidance. And this is the sort of application that gets immediately pushed into the cloud, because then it's like, oh, we'll make I'll get the drones that are near me, I'll make an API call to see if it's the bad dog, and then I'll avoid it. And that's amazing as long as you're close to the servers. But here's the planet. The dark parts are where the people are. That's sort of roughly the population of the planet. And if you're walking a dog in New Zealand, and it has to go back to Amazon AWS East to find out about the bad dog, then that delay is so large that it's quite likely your dog has an argument with the other dog, right? It's too late. The dogs have met. It'd be far better if you went to a server that was close by, either in New Zealand or Australia is much, much closer. So if you can move applications around. Now, really what you don't want to do is have to make decisions like this. You don't, as a programmer, want to be like, oh, I need to have my application running in Australia, blah, 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 because I've got some customers now. It should just be transparent. It should be this one big global computer. So I think that's sort of the promise of serverless. It's not really there are no servers. It's just that you don't have to think about where the servers are. They're just somewhere in the internet. And as soon as you do start thinking about where they are, you've got a silly hardware problem. So I want to talk about one interesting thing. So this is a real graph of, this happens to be the UK, but it's the same story everywhere. The increase in global internet connection speed. This is download speeds over a 6-year period. It's just going like this, right? Everyone's getting higher and higher bandwidth. Everyone has experienced this. They can walk down the street streaming music on their phone, where it's great. Streaming video on their phone, watching multiple Netflix things at once at home because of this bandwidth, right? But the bandwidth has become really, really high. But they've also experienced another problem, which is that even as this has gone up, interactive things are still slow. It's still like you get out your phone, you're like, I'd like to get a taxi, and there's this pause while something's happening, which is a bit weird, right? Because how is it that that's still slow, but the bandwidth has gone up? And the problem is, we've done a fantastic job on bandwidth, increasing it. We've done a really, really, really bad job on the speed of light. This is the change in the speed of light over the same period. And I stopped in 2016 because we were making no progress. And this is a real problem. It turns out that the speed of light is way too slow, and we failed to increase it. And the only option is to bring the things that you want to interact with close to you. You literally have to move close. So just like the dog, the dog being walked in New Zealand is actually going to have an argument with another dog because the speed of light is way too slow. So that is why you fundamentally have to move stuff around. And sort of the promise of serverless is, let's just put everything everywhere. So just to tell you briefly, I'm not going to do a pitch about Cloudflare, but Cloudflare has 166 locations worldwide. There's actually a few more in West Africa which are not on here because I haven't got an updated graph and because the marketing people are going to shout at me. But there are more things like that. The idea is this isn't global thermonuclear war. This is actually 10 milliseconds in copper from those data centers. So the idea is we want to be within about 10 milliseconds of everybody who's using the internet. And this year we're finishing off West Africa, bits of South America and Central Asia, and particularly India. So you have geographic closeness. And then the fun thing is, I want to be able to just run an application anywhere in that network. And that's what the Cloudflare Workers product does. Who saw Hugo Romano's talk earlier on? Anybody go to that? That's worth watching on the stream because that's about actually using this technology. So if you think about just what we are, if you think about the way in which the cloud providers have built things, they've built out these major regions, and depending on which one it is, they have more or less of these regions. And then what we've done is built out just like within 10 milliseconds, everybody on the internet is the idea. Now, if you want to do this, if you go back to that Gigatron experience, when he ran BASIC, it was immediately running. There was no even though it was a slow CPU, there was no startup time. So if you want to have service technology, I think what you really need is instantaneous startup, right? You should be like, here's my thing, it needs to start. It shouldn't be waiting for it. Thousands and thousands of tenants, and it needs to be secure because it's your code that's going to be running there. So it turns out that the environment where this sort of problem is being really, really investigated is in browsers, because browsers are running untrusted code all the time. Code is downloaded, random website you go to, you download code, you execute it. And you're doing it on a machine where if you can break into my machine through that code is really valuable to get it. That's why if you go and look at the competitions around breaking into browsers, it's really fascinating how much effort goes into this. So what Cloudflare did was we took one particular engine, which is V8, which is the engine which is used in Google Chrome, and we deployed that on all those servers around the world. So we built a bunch of technology around it. But the idea is you can write some JavaScript, upload it to us through the API, through our IDE, and it will execute on every single machine globally. And it will respond to requests coming in. And so we're using V8 to do that. Because we're using V8, you can also use WASM. So you can write in Rust, you can make WASM, give us the WASM, and we'll execute it for you. And you won't ever know which server it got executed on. Now, this is great, and anyone who's written anything, again, the Gigatron thing, there were no real variables in that. There was like the loop counter. There was nothing stored between invocations. And so the big thing that's missing is to have storage. And again, storage suffers from the same speed of light kind of problems. So, typically what happens in a Cloudflare application is, the user connects to us, we connect to the app connects to some database, whatever database is, some storage mechanism. And now what we've done is we've moved the app, the serverless bit, into Cloudflare, right? So it's everywhere in the whole world, but the data is still really, really far away. So if you have to access data, you have a problem. So you have to solve that problem. So the idea is that, so just to give you a really extreme example, we don't actually have a cache on Mars, but let's suppose we did have a cache on Mars and there were users on Mars, then they would be having a really bad time because the round trip time between their application running in a serverless environment on Mars would be 6 to 45 minutes, depending on the position of the planets, which is going to suck, right? So, that's going to make Elon really unhappy, because he plans to go to Mars and he's going to be trying to access websites, and it's going to be really, really slow. So we want to make Elon happy. So the equivalent of Mars, this is not to say anything bad about people from New Zealand, but the equivalent of Mars on Earth is New Zealand. It's really, really far away from everything else. So this is a real problem. It's not a theoretical problem, the Mars issue. So basically what we've done is we've built a technology which allows you to have data local with the code within our network. So you can store data and then you can sync it back to a central database. So you can build real applications in a serverless fashion, right? They're not just stateless functions. They can actually have state as well. So there you go. And obviously we can deploy that on Mars, and then Elon is happy, right? So obviously that's great, because then he doesn't tweet bad things about you, and that makes you happy. So just to think a little bit about this world of functions as a service, the one thing to think about is, and I think as a developer this is not obvious what the answer is what should you be writing as a serverless function, and what should you put in a device, like a phone or a laptop, and what should you put on a server? And there are some characteristics of these different locations that are interesting to think about. So today, when you write an application, like suppose I write something for the phone, I might write an app, there's a bunch of stuff running here, then there's an API which hits some server which is running somewhere. With the advent of functions as a service, you can say, I can put some part of this into the network somewhere. It could be close to the device because there's speed of light, 10 milliseconds from here, so that's interesting. Or I could put it far away. Oh, Sophos, we love Sophos, don't we? Hello, Sophos. So the server, right, in your traditional AWS or whatever, it's secure. You can put secrets in there, right? It's really fast to update. It's probably linked into your CI pipeline. If you find a bug, you can reboot it. You can change the code in there really rapidly. But it's far away from the user. The dogs are biting each other in New Zealand while your server is making a decision. So that's sort of where we are today. And then, let me see. And then if you think about the browser or the phone, it's very different. It's insecure, right? If it's a browser, somebody might have an extension that stops part of your code running. Right? Oh, I've got some anti-ad blocking thing, I've got something, I'll just stop a bit of your code running. It can be inspected. On a phone, it can be extracted and inspected. So you can't put a secret in there, right? And if you do, it's probably a bad idea, right? So you're not going to have some API token in there or something like that. It's relatively slow to update. I mean, users will update at varying speeds, even with auto-update, right? If you find a bug, you're going to wait for an update cycle. Some people don't update. Some people choose not to update. I've had people tell me they don't update because when people bring out the new versions of the application, they only do that to slow your phone down. I mean, people really say these things. So you get slow to update there, but it's super low latency to the user, right? Super interactive with the user. So today you've got those two worlds, realistically, and then what I think that functions as a service does is it kind of mixes this together. So on the one hand, it's secure. You're running code on a trusted machine. It's not on the end user untrusted device. It's really fast to update. You can push out new code to that thing, essentially at the same speed as you can push out to your own server. So if you find a bug, you can update it really, really fast. But it's low latency to the user. It's not as low latency as the device, which is in their hand, but it's pretty low latencies. So what's interesting to ask yourself as a developer is, how do you cut up your application, and what do you put where? And I have some examples of like what people have really done with this. So let's just talk about the real world of this for a bit. So there's a thing called Factorio. Does anybody play Factorio? It's a game. Anyway, it has this incredible, there are these incredible maps, which are just like a kind of a Google map, where you make these factories, and they're super detailed and zooming. And the guy who made this thing, Factorio Maps, which allows you to look at these superb things, was getting killed by the cost of doing it because of the richness of the interface. And what he realized, there's all these different zoom layers with the different tilings in it. What he wanted to do was he wanted to do a couple of interesting things. One is he wanted to play off storage providers against each other, because he's got all these tiles and these different storage providers. And some of them are faster, some of them are slow. And depending on where you are in the world, they may be faster or slower. And so what he did, this is his actual code that runs in our network. He plays off Google Cloud Storage and B2, which is Backblaze's S3 equivalent. And he literally tries to get a tile from both of them, and he uses promise.race, and he's like, whichever one I get it from first, that guy wins in my location. And then I can display the tile to the end user, and then it will put it into the local cache on the machine. So this is literally code that he runs as a function. And so when he's pulling things, he pulls them from the different providers. The other thing he can do is he can play with the cost. So he can look at it and be like, well, actually, Backblaze is cheaper, so I'll pull it more often from Backblaze, or I'll allow it a certain amount of time. So this is real JavaScript code pushed out as a function. At the same time, he sends logging information to StatHouse, so he wants to know what's going on. So rather than do that in his application, he does it within the JavaScript that's running on the edge around the world. And he just pushes back, okay, this thing happened. What's interesting here is he actually pushes this back after he's served the response to the user. So the user gets the tile, and then the script in our servers keeps executing and does some other things for him. So he pushes it out to StatHouse and says, here's what happened. We've got quite a lot of people who are doing this. What they're doing is they're embedding some canary secret in their database, and then they're seeing if it ever passes out through their application. So they've got some application running. It's running a server. They've got a little piece of JavaScript in our code literally looking for, it literally goes and gets the response from their server, and then it goes through and says, does this secret thing that should never be leaked, is it appearing within this particular document? So this is a way of seeing data that's actually coming out. So it's running in parallel with what they're doing. Now, they don't actually use, is this a secret, but they use some other kind of thing. And if that does appear, they serve up a 403 page saying you've been blocked. So the leak doesn't actually happen. Otherwise, what they'll do is they'll just serve up the real page. Again, this is the actual code with some slight modification to the actual secret they're looking at. There's literally just that little code. If there is a leak, they make a PagerDuty incident immediately. They call PagerDuty and say, we're leaking. Again, this is how it does it. It just makes a post request, and it uses wait until to actually send a PagerDuty request. So again, this is the kind of thing people are doing. Geo-targeting is super common, because if you think the code is running everywhere in the world, the way in which you typically would do geo-targeting is you would figure out the user's country, and then you would then go and see, have I got a page in that language or localized to that location? And what we've had quite a lot of people do is exactly this piece of code, which is we provide them with the country, that's right at the top there, the CFIP country, so they'll know what country it's coming from. And then what this does is it tries to get from the customer's origin server a version localized for that language or that country. If it 404s, then they say, okay, we'll serve them English. And if it doesn't 404, then they get the localized version. What's neat about this is that they don't have to actually update anything. If they push out suddenly a Portuguese version, everyone who comes from Portugal goes, oh, suddenly gets served Portuguese. They haven't actually had to change their configuration of their server and change links or anything. And so this is a real code for what they're doing. Another thing people are doing is they're building web pages dynamically on the edge. So what they're doing is they're calling multiple APIs, putting together a page and serving it up to the end user. One customer who's doing a huge amount of this is Discord. I assume most people have used Discord or played around with it. Hugely popular with gamers. We found out by accident that they had moved a lot of their infrastructure off of their servers into our serverless platform because one of their developers mentioned it on Hacker News. It's like, oh, by the way, we moved it. And one of the things they moved was the entire public website of Discord doesn't have any origin at all. It's entirely running serverless with inside Cloudflare. So one thing people are doing is they'll put together web pages. So there was this old technology from Akamai called ESI, which was a weird sort of HTML thing saying, okay, here's a bit of a page, and insert here, go get something else from an API or from another web page and insert it here. And this is very easy to change. So what people do is they actually write JavaScript that runs on our edge that goes and gets the page, literally searches for those things. When it finds something, goes and gets it and inserts it. So you just dynamically put the page together on the edge. And the reason that's super fast is our connections to the internet are really great, right? So we have really fast connections to lots of APIs, and so people can build these pages together. I can give you all this code. This is literally the code that executes. It's all simple JavaScript. And then they just do a sub request, and they can do arbitrary numbers of things, putting things together. To return to drones, Drone Deploy is a real company. It's not a dog-walking drone company. It's actually a company that does surveying. So this is a picture of a solar electricity station. And you can see the solar panels here. So what they've done is a drone has flown over with an infrared camera and looked at the temperature. And one of the ways in which you find dead solar panels is by the temperature being wrong on the panel. So as they absorb the sun, they have a certain temperature, and if they stop absorbing the sun, they get a different temperature. And so what Drone Deploy does is in the field, they deploy a drone, and they get a composite picture. This is a very large area. To give you an idea of the large area, that white thing on the right there is a car. There's a car sort of just over there. So there's a huge space. And so one of their things is that the security of this is very, very important. So what they're doing is they're verifying a JWT on the edge. So it never gets to their server. If their app is not authorized, it never actually hits their origin. We will do the JWT right inside our server. And it's fairly simple JavaScript stuff to actually check the authorization header. And then if it's not, then tell them to go away. Now I thought what I'd show you is actually something that we built as a completely originless website using this. Now I'll actually tempt fate by live coding slightly. So in the US, there's a lottery called the Mega Millions, which at some point rolled over to $1 billion. And people went crazy. The prize was $1 billion. And so people were buying tickets. And we have in our San Francisco office a wall of lava lamps. And the wall of lava lamps feed a random number generator. So there's a camera looking at them, and the lava moving creates random numbers. And so we thought as a joke, we would make this website, which then, of course, accidentally went viral, called lavamillions.com, which is if you needed numbers for this Mega Millions draw, you could go to this website, and we would, using these lava lamps, serve you up random numbers for the lottery. And how would you do this normally? Well, normally what you would do is you would put it on a server somewhere and execute it there. But I decided we would just do it with some JavaScript, and we can make it happen. So what I'm going to do is I'm going to switch out of this presentation. Let me just show you Lava Millions for a second. So that's Lava Millions. I can just refresh it. Now, this is executing entirely as a serverless function in some Cloudflare server somewhere. And every time I do it, I get a different set of numbers being loaded. And I can actually figure out which server it is if I just run this thing. So if you ever come across a Cloudflare website and you add cdn CGI/trace, it will tell you where it executed. And so this ran in LHR, so that ran in the London data center of Cloudflare. So actually, I'm being routed from my laptop to London. I could have been routed to Lisbon, Madrid. It happened that we're going to London. And it's noticing that I'm in Portugal and all these other things that are interesting. So that's executing on let me just come back down here to something decent. So that's executing on a server there. Now, what does that look like? Let me go into the interface. So how does that look up there? So this is the actual code that builds the website in the IDE for Cloudflare. This is I'm logged into my account here, and it's what it does is it goes through when it just adds an event listener. Now, what's interesting about this is we built this on the Service Workers API for the browser. So when it executes on our Edge machine, it's exactly the same as if it's executing in the browser. So I can actually live code in the browser, try stuff out, and then deploy it to the Edge, and it will execute the same thing. So I'm going to try doing a live deploy. So let's just try and change something. So I will go in, and I'm just going to change where it says, here are your Mega Millions numbers. I'm going to type in, hello from Lisbon. Okay, so we'll just push that in, and then I will hit deploy. All right, and so that's now deploying across the 166 locations worldwide. So what we'll do is I'll refresh this and see, okay, it did it. Okay, so we see it says hello from Lisbon now. So it deploys in about, under 5 seconds globally. So that would have deployed everywhere. It's probably in New Zealand by now, takes a little bit of time. So the nice thing about this is it means that as you're developing, you can really, really interactively get feedback on your application. Now, at the same time, you might not want to actually deploy. Let's just change something again, actually. I like causing trouble. Let's pretend the lottery had more numbers. Let's have an extra number here. Let's do 6. Whoops. Go back to the editor. Go into here. Yeah, 6 things there. So previously it's like, oh, it's already deployed it. So what you can see here, I changed it so it actually chooses 6 numbers in the golden ball. And because we can run it in the browser, because of Service Workers, it's actually executing and now getting 6 numbers. But on the live site, there's only 5, the white balls. So you can actually interactively develop here. And I can go in here and be like, okay, actually, I'd like to know what numbers it chose, and just go console.log lotto nums. Right, and just run that. And it printed it out in the log here. So you can do all the interactive browser things you want to do here. And then if you like this, if you like now that it has 6 numbers, then I can just deploy it. We'll push it out again. And now, again, the same thing is happening. It's now deploying to those 166 locations worldwide. Let's see how long it takes to, okay, it's deployed. So it's deployed, so now it's producing 6 numbers. And so I think what's neat about this is it gives you more of the experience of like that Gigatron experience of like, I can write code now and I can just have it running anywhere in the world quickly on our servers, wherever they are. All right, I'm going to live fix this so that anybody who's generating their numbers doesn't get the wrong number of numbers. Let's go back and do that. Let's get rid of that. Just update the preview so you'll see it change in the browser version. Looks good. Oh, let's take out the console log. Take that out. Just check that it still works. Okay, and let's live deploy it. And let's just see when Hello Lisbon disappears. Yep, it's done. So it gives you a sense for the speed of development you can get with that. And the talk earlier on from Hugo gave more examples of this kind of thing. All right. And that is me done. Thank you very much. Do you have questions? Are there questions from the audience about that? No? Okay. All right. Great. Thank you very much. You have a question?
Yeah, so I'm going to shout at you, you get shouted back. So you add environment variables over there, right? On the thingy?
On the thingy?
Yeah.
Do you want me to bring up the thingy?
Yeah.
All right. Can I have the thingy? Can I have the...
That one with logger?
Oh, the one with the logger?
Yeah, you had
Yes.
the example with the logger, and it adds some secrets there for the logging. No, PagerDuty, I think. You had the example with PagerDuty, and it had like the credentials for the PagerDuty account.
Yes.
So where does that get stored?
So that's an example of pulling something from the database functionality that I talked about. So you can have secret information in a database which is accessible from your script, and then when the script executes, then it gets pulled. So there it's actually just a bound variable, basically. So you can actually bind a variable to something in the database, or you can call .get and pull out something with a more complex key.
Okay, and I would imagine that would involve some sort of physical security around the database and all that, and blah, blah, blah.
Well, so the question is about physical security. So, I mean, that's sort of Cloudflare's whole business, right? Because probably more important than your PagerDuty key is that we handle the SSL keys for 14 million websites. So keeping those secure is fundamental to what we do. So yes, it all built on the same infrastructure for securing that kind of stuff. We have this technology which we keep thinking we're going to open source, and I think we probably will, called Quicksilver, which is the way in which that deploy happens so fast, where I hit a button and globally something was deployed, was we have a distributed key value store that replicates globally in a few seconds. And that itself is encrypted, there's encrypted links and all that kind of stuff. But it's fundamental to what Cloudflare is built on, is that ability to press a button and change globally at that speed.
Okay, thank you.
Thank you. There's a question at the back there.
Good afternoon, first of
Hello.
all, and congratulations for the great product that you guys are doing.
Thank you.
I think it's amazing, and about the innovation that you are sharing with the community as well. One of the things when I look into serverless is, I think it's really important, is the vendor lock-in. You guys here are using V8, okay, it's kind of open as well, but is there any plans to do some kind of framework or something that allows Cloudflare to say to everyone, okay, we are Cloudflare and we want to be open with everything, and actually try to make it?
Yeah, so that's an interesting question. So one of these, as you say, we used V8. We use the Service Workers API, so you're writing to a standard API. There are a bunch of things going on in serverless, right? So there's actually a company called Serverless, which we integrate with, so you can deploy to different kind of serverless backends. But I don't think there's yet been developed kind of a common standard for the way in which to do this. I mean, the internal debate at Cloudflare is, should we just open source everything we've done here and say, this is the standard, right? This is the way in which you do it. I don't think that's usually our style. We usually try and work with whatever the community wants to come up with. Having said that, Dollar Shave Club, who are the folks who do the razors that you get sent every month, they've built an offline version of Cloudflare Workers, which you can download. It's on their GitHub. So you can actually do the whole development offline, and then you can actually just push out. So they wanted that as part of their workflow. They could do testing and stuff like that. So maybe that's a sign that it turns into something more generic than our own thing. If you think about vendor lock-in, the real thing that will accidentally lock you into a platform is the APIs you're calling, right? So I think all of the examples I gave there, you could take that code and run it somewhere else. It's just JavaScript, and it's not using very Cloudflare-specific features. So the thing to look at for any platform is, are you getting locked in by, oh, I'm tempted to use this thing, and I can never actually leave again. So one of the things we're talking about internally is, for example, we'll roll out more and more database functionality into Workers, and I've pushed very strongly that the API that's being used is something that you would recognize. So, oh, it's the Redis API, or it's the Memcached API, so that it can be moved around more easily. And those things have been tremendously successful if you allow people to leave. And then one of the things Cloudflare has always done is you can turn off your account, right? You can switch off like that and be gone. We've never tried to do things that make people stay. So whatever develops here, we'll play along with it, because I think it's our advantage that everybody has a platform they can work with really easily, which is one of the actually reasons why we chose to do it with JavaScript as well, because JavaScript is by far the most popular language there is, and you know, anyone can pick this up. I mean, I wrote that that website, which is stupid. I'm not a JavaScript programmer. If you looked at my JavaScript and you're a good one, you'd probably be horrified things I did in there. But it shows that anyone who knows JavaScript can quickly produce something valuable. And they're not thinking about scaling. They're not thinking about cold start time. If you want to look at that, I can look at, there's a very good, somebody's done some benchmarking of this stuff and show you what the cold starts and warm starts are. Because of the way we're doing it, the cold start is about 5 milliseconds. So it's really fast. It's just like not, no messing around. We want it to be there. It's, the silly slide with the meme with the people saying, what do we want? We want to write code. That's what we want to have, just write code. Other questions? There's one down in the front here.
So the way functions work on Google or on Amazon, they run on their own huge data centers.
Yes.
And you run them on your local point of presence.
Yes.
So for instance, in Lisbon, I know you have a POP here and
yes.
a third-party data center.
Yeah.
But that's usually one rack or two. So how you scale that, and you don't need the whole data center to do it.
Right. So the question is also related to how does Cloudflare scale in general, right? Which is that we actually dynamically move traffic around without anybody knowing. So the reason I actually went to London rather than Lisbon, and I'm in Lisbon, is that website, Lava Millions, is a free website on Cloudflare. And because it's a free website, we actually moved it to London where we have higher capacity, but it'll be slightly longer latency. Now, if I started paying for that website, it would suddenly appear in every data center in the whole world. So we dynamically move stuff around. So in terms of scaling, one of the things we do is it's really a question of where your traffic is concentrated. If it turned out that all of your traffic was concentrated in Lisbon, right, you did something specifically in Portuguese for the market here, you would end up hitting our data center, and we would, on the scaling side, be looking at, do we actually have capacity? These guys are growing. Do we need to send more servers? All that kind of stuff. Most of our customers are fairly distributed. And if there was a problem, I suppose we hit a capacity limit in Lisbon because your company grew rapidly, we would start failing over some of your traffic to Porto, and some of it to Madrid, and we would start moving it around dynamically. Ultimately, we'd buy more servers and make sure we had the capacity, but we have the ability to do dynamic scaling across the globe already, so we can move things very, very rapidly. In fact, we do it all the time. We move things around. Is there another question? It's hard to see from up here. No? All right. Perfect. Thank you very much.